All right, so in the previous video, we already covered the very first type of important graph or figure that we learned last week, okay, which is the stem plot. All right, then for today, we are going to continue with another type of graph, which is histogram. All right, so let's have a look for the learning outcome 1.2. So we need to learn how to draw the histogram from a group frequency table. And after that, you need to know that the area of each block is proportional to the frequency. Area is proportional to the frequency. What does it mean? Later we'll learn about it. Okay, then to be able to construct and interpret histogram from cumulative information given. All right, so if let's say when they try to combine histogram with cumulative graph together, you need to know how to interpret both of them, either from histogram to cumulative frequency or from cumulative graph to histogram, either one. So to me, I think for today, we are going to focus on only the first part. The first learning outcome here in 1.2, and then the second learning outcome, we are going to learn it after we learn cumulative information. Okay? All right, so let us start with the basic important terms about the histogram first. Okay, so for histogram, generally, when you have a lot of data, okay, and when it is too many already lah, so usually people will try to group them in classes or summarize all the data in a table, and we call it as frequency distribution. Okay, so when the data set is large, a stem and leaf diagram, the stem plot will not be the best method to display data anymore, because you need time for you to put in the data one by one into the stem plot. Okay, so that's why we need other methods. So usually for a large set of data, we will actually try to divide the data into different groups, and we call it as classes. Okay, so when you want to draw histogram, generally we need to have the class boundaries. Okay, so this is a very important word. Please make sure that you know what is the meaning of class boundary. Okay, so we have upper class boundary and also lower class boundary. So what is upper class boundary and lower class boundary? We'll learn about it later. Okay, so please take note about the class boundary here. Okay, the important fact about the class boundary is the upper class boundary of one interval is the lower class boundary of the next interval. So later I will show you also okay, what's the meaning of this sentence. So generally this sentence is very important. It is the definition for the class boundary. Okay, so class boundary is also very important because of we need to use it to draw all kind of graph in our A-level syllabus at this for now. Okay, all right, so let us continue. Okay, so now we have to understand that when you want to draw histogram, okay, histogram generally when you draw it, what is the difference between histogram and also the bar chart? So for bar chart, you will see that there are spaces between the bar, okay, and then for histogram, generally there's no space between the bar. Although it looks like a bar chart, but there's no space between them. All right, and all the value between the bars, we call them as class boundaries actually. Okay, so you can see that all the value here are class boundary and there's no gap between all the boundary. Okay, so that's the difference. So this as histogram. Okay, if you got space one, we call them as bar chart. Okay, so when you want to sketch histogram, the very first thing is you have to make sure all the value here and all the bar here has no gap. Okay, so sometimes you need to do some adjustment, okay, to get rid of the space between all the bars. Sometimes you need to do the adjustment, something you don't need. All right, it depends on the data that they give you in the question. Okay, so as an example, if let's say in the question they give you this set of data, 120 to 134, and then 135 to 129, and so on. Okay, so if they give you this data, the classes here, do you need to do the adjustment to get a class boundary or not? So very simple actually, you just try to imagine. Okay, if you draw this one as the first bar, 120, 124. Okay, so let's say this value is 124 then the value in front is 120 So what's the next class? The next bar will be 125 to 129. So what is 125? it will have some gap between 124 and 125, right? So the next one will be 125 until 129. So according to this data, you will see that if you draw the bar chart, if you draw the bar according to the value that given here, right, there will be some space here. Can you see the space here between the bar? Which is not correct, because histogram shouldn't have any space between the bar. Okay, therefore, you can imagine if you use this original data and draw the histogram, it is wrong. It is a wrong histogram because there's gap in the bar. Therefore, you cannot draw the histogram by using this data. So what you need to do is you need to do some adjustment for this case. So how to do the adjustment? When you want to do the adjustment, all the value, okay, all the starting value for every single classes, you minus 0.5. All right, and all the number at the end of the classes, you plus 0.5. In general, it's like this, we do it like that. Okay, therefore, when you want to change it become class boundary, suppose you have 119.5 and then to 124.5. And then the next one will be 124.5 to 129.5. Okay, 129.5 to 134.5 and so on. Okay, so if you continue everything, 139.5 to 144.5. Okay, so after you do the adjustment, right, then you ask yourself again, if you want to draw the histogram by using the value after the adjustment, is your bar still have gap or not? So you simply draw. So let's say first value here is, let's say this value here is 119.5. Okay, sorry, wait. Okay, so let's say I draw the bar, the first bar. Maybe the first value here is 119.5, and then this value itself will be 124.5. Okay, how about for the second class? If you want to draw the second class, second bar, it will be from 124.5 to 129.5. So you already know that this line itself is already 124.5, right? So when you want to draw 124.5 to 129.5, you will draw it on the same line. Okay, so this is 129.5. Therefore, you will see that there's no gap between the bar, which means this is your class boundary and you should use it to draw the histogram. Okay, so you need to compare. All right, if let's say the original question, they give you something like this, because got gap right between the bar, therefore you have to do the adjustment. Again, how to do the adjustment? All the lower value, you minus 0.5. All the upper value, you plus 0.5. Upper value in the class and lower value in the class, okay? Then after you do the adjustment, right, so we call this new data, new value as class boundaries. Okay, so the word class boundaries means that when you use the value to draw the graph, there's no, there's no gap between the bar. Okay, and then in our notes just now, what we say is like the value for upper class boundary. Okay, so maybe before that, I will tell you first. Okay, all the value, okay, that starts, the starting value for every single class boundary, we call them as lower class boundary. Okay, so so this one is lower class boundary. Okay, and then all the value here at the end of the class, we call them as upper class boundary. So according to the definition that we have in our notes just now, what they say is the value for upper class boundary, okay, this is upper class boundary, right, the highlight one, it will be the same as the lower class boundary for the next class. So can you see that? So these two values should be the same. The upper should be equal to the lower for the next interval. So this is the definition for class boundary. All right, so hopefully you understand the concept here. All right, okay, then let's have a look for the next part. Okay, let's have a part number 2. If let's say in the question, they provide you this Then again, first one is 120 to 124. The next value is 125 to 129. So again, you see 124. The next value is 125. So very obvious, these two values are not the same. That means they are not the class boundary. Okay, so when they are not the class boundary, because not the same. If let's say these two values are the same, they are class boundary in short. Okay, therefore, this example, you also need to do the adjustment. Again, how to do the adjustment? So this part, again, minus 0.5. And this whole thing, you have to plus 0.5. Okay, so after you do it again, you have 119.5 to 124.5 again. And then 124.5 to 129.5, and so on. Okay, sorry, this one should be 139.5. Okay, to 144.5. Okay, so this is what we need lah. All right. Okay, so generally, if you compare the first two example here, both of them, okay, have gap for the upper class boundary compared with the next lower, for the upper value compared with the next interval value, lower interval value, they are gap. That's why you need to do the adjustment to change become class boundary. Same thing happen for part number 2. You also need to do the adjustment, right? Okay, so let's have a look again now for the way that I write out my class boundary. So you will see that when I try to write out my class boundary here, okay, I use a very simple, simple symbol. I just use the symbol like this only, 119.5 to 124.5. Okay, no matter the original value give me what kind of symbol, I just write the simple one. So what happen here? This one looks like very complicated, right? They use the equal, non-equal sign. Okay, smaller equal than and greater equal than. But when I write it in class boundary, I just write a simple sign. So what's the meaning? That means for class boundary, actually the main idea we are using it to sketch graph only lah. So the sign, how are you going to write it out is not important lah. So usually I will just use a very simple way to express it like this. Okay, and then some students will say, teacher, you know, if I follow what they write in the question, it will become 119.5, the x, and then 124.5, and then 124.5, and then x, and then 129.5. Then a common question that student will ask me is, you see, the 124.5 appear here, got equal sign, here also got equal sign. Then what should I put the 124.5? If let's say I get the data which is 124.5, so which class should I put it in? Okay, so again, when we are dealing with class boundary, don't use all these complicated symbols. Okay, use the basic one will do. Okay, so the class boundary is not for you to put in your data into the class. Okay, it is just for you to sketch your graph. All right, so if you want to put your data, okay, in here, into the classes, like, okay, let's say you're having a length, the height 124.5. Okay, so for the 124.5, you shouldn't put it under the class boundary side. Okay, so what you should do is, like, you look at the 124.5, they say you have to put into the nearest end, right? So 124.5 is actually 125. So for value 125, where should you put it? You should put it under this class. Okay, so when you want to put the data into the classes, you refer back to the original class that they give you. Okay, don't confuse it with class boundary. Class boundary mainly is for you to sketch histogram, okay, and also to do some calculation later. All right, but when you want to put data into the class, you are referring to the original class that they give you in the question. Okay. All right, so these two are the example how we actually try to adjust the interval become class boundary. Okay, and then please take note that not every time, okay, not every time you have to adjust the interval become class boundary one. So these two are the example that you need to do the adjustment, right? Plus 0.5 and minus 0.5. But if you have a look for question number 3, part number 3 here, in the question, okay, again, they give you all the data like this, all the classes like this. Okay, so how can I make it into the class boundary? So again, before you do any adjustment, you check first the value for the upper class, okay, and the value for the lower value for the class. Okay, so you compare these two values, they are actually the same, right? Okay, so when they are actually the same, it means that when you want to draw the graph by using the data given here, the class given here, so the first bar is 120, then this one is 125. And then for the second bar is 125 to 130. So you can straight away draw the second bar, which is the value here is 125, and then this one is 130. So do you have any gap between the bars or not? No, right? You didn't see any space or any gap between the bar, which means what? Which means that for this class, you no need to do any adjustment to change it become class boundary. Okay, so which means you just copy it down. 120 to 125 and so on. Alright, so again, not every time you have to adjust the value by minus 0.5 and plus 0.5. If there's gap between the bar, then you have to adjust. If there's no gap, then you just no need to do anything, just copy them. So you can see that the value that for the class boundaries is actually the same as what we have given by the question. Okay? Alright, how about next one? Okay, so the last one, again, in this question, they give you all this as the class. Okay, all this as a classes of interval. Do I need to adjust it by using plus and minus 0.5 or not when we want to get the class boundary? Okay, so again, you double check the upper value for the first class, compare it with the lower value of the next class. These two values, are they the same or not? They are the same, right? So do you need to do any adjustment to change it become class boundary? No need. Which means you just copy the value, okay, according to what they give you in the question. The class boundary will be 119.5 to 124.5 and so on. Alright, so when I write it out, I will just copy it. No need to do any adjustment. Okay, so this is what we have for our class boundaries. Alright, it is a very important part for histogram. Before we start to learn how to draw it, that's the first thing. And the second thing is we are going to use the class boundary very frequently in doing some calculation for the statistics later. Okay, alright, so again, for this whole page, please make sure that you understand what is the meaning of the class boundary. Alright, okay. So first important terms is class boundary. Okay, next one. When we want to draw the histogram, right? Okay, or maybe when we want to do some calculation, okay, generally you need to know what is the meaning of class width, or usually called as width. Okay, so class width formula is upper class boundary minus lower class boundary. Okay, so I think you need to have this formula and try to remember it. Okay, so this is very important. Why? Because when they said, okay, let's say you are having the width of the class, okay, which is 120 to 124. This is the class. Okay, maybe we take the example on top. 120 to 124. Okay, so let's say this one. This is the class, right? 120 to 124, and the next class is 125 to 129. Okay, so these are the classes given. So you need to change it become class boundary law, right? Because there are gap between the values here. Okay, so now when we take the 120 to 124, and we want to calculate the width, right? Okay, the width should be 5, which is 124 minus 124.5 minus 119.5, which is equals to 5, but it is not 4. Can you see that? You are not taking 124 minus 120. Okay, you should take 124.5 minus 119.5. Why? Because this is actually the class boundary. So according to the formula, width should be the upper class boundary minus the lower class boundary. Okay? Alright, so that's why just now I said class boundary is very important, because if let's say you didn't know the meaning of it, then when you want to calculate the class width, right, the value will be wrong if you will use this one, which is wrong. Okay? And if your class width is wrong, then very soon when you learn to calculate all the mean, all those things, right, everything will be wrong. Okay, so the words or the terms here, okay, it looks like very simple, okay, but the details are very important. So make sure you understand, okay, the details in it. Okay, then next one. When we talk about histogram, right, generally, it looks like bar charts, but actually there are some important differences here. So in histogram, there's no gap between the bar. So I think I told you just now already, right? Histogram, there's no gap between the bar. And another thing is you need to know the area of the bar is proportional to the frequency, which means if let's say the frequency, the value of frequency and the area of the bar, they are proportional to each other. So what does it mean? Later I will explain it to you when we learn some concept later. Okay, so now we talk about something important here. Okay, so I believe that most of you learned histogram before. Okay, no matter you are from IGCSE background or maybe you are from SPM background, generally you learn histogram, if I'm not mistaken. All right, and then for A-level syllabus, right, generally they are going to introduce new type of histogram actually. New type means that something slightly different from what you learned before. Okay, so maybe for me, I will separate it into two parts. So we talk about histogram. Okay, generally we are having equal width histogram. Okay, and another type actually required as unequal width histogram. Okay, so we have equal width histogram and also the unequal width histogram. All right, so equal width histogram is something that you learned previously in SPM or maybe IGCSE. So that means you're having all the bar. Okay, then you just draw it up by looking at the frequency and everything. Okay, so your label here will be frequency for the y-axis, and then for the x-axis here, it will be either the class boundary or maybe the definition according to the question that you have. Okay, so for A-level, this one is SPM or IGCSE. Okay, and then for A-level, they actually prefer to ask students about unequal width histogram. So what is the meaning for unequal width histogram? Okay, unequal width histogram means that the bar is not always having the same width. So some bars are very slim, and then some bars are fatter and so on, or thicker. Okay, so this kind of graph requires an equal width histogram, but it is still histogram, they are still bars, just as some bars are very slim, some bars are very fat. Okay, and then for unequal width histogram, generally the y-axis, right, the label that we are using is not frequency anymore, but we introduce frequency density. All right, and then for the x-axis, it is still class boundary. All right, so this is the new type of histogram that we should know for A-level syllabus. Of course, sometimes they will still ask you for equal width. All right, but most of the time they will ask you for unequal width because more things to ask and more things to test. Okay, all right. So the new things here, the new terms here is frequency density, all right? Okay. So what is the meaning of frequency density? So frequency density is actually the formula for us to calculate the height of the bar, which is frequency okay, divided by the width. Okay, so you can see frequency divided by the width. This is a new formula that you never learned before, so you are going to learn it later. Okay, so if you try to change it, become non-fraction, so you're having frequency equals to frequency density multiply with width. That means if you bring this up, it will become frequency, okay, equals to frequency density multiplied with width. Okay, so you see, what is the frequency density? Frequency density is the height of the graph. Okay, what is the width? The width means the width of the graph of the bar. So when you take the height multiply with the width here, this whole thing is actually the area of the bar, right? Therefore, you can see that the frequency density, okay, is equal or proportional to the area. All right, so that's the meaning for the fact that we learned just now. Okay, so no matter how, to me, the most important thing is you need to know what is the meaning, okay, or what is the formula for the frequency density, because we are going to use it to calculate and draw the histogram later. Okay, so this is the difference between the histogram with equal width and also histogram with unequal width. All right, so for A level, they prefer to ask students about the unequal width histogram. All right, so make sure that you know all the details here. Later, of course, I will show you how to draw it out in detail. Okay, all right. So now, if the class width are not equal, okay, then we need to draw frequency density. Okay, we need to draw the bar by using the frequency density, not frequency anymore. So how to get the frequency density? You have frequency divided by interval width. So these formulas, please make sure that you remember it because it will not be provided in the formula booklet. Okay, and then just now I told you already, right? The width and frequency density. The frequency density is like the height lah. Okay, so the width is the width. So when you have width multiply with height, it is equals to area of a bar. So the area is actually proportional to the frequency. All right. Okay, so this formula, no need to purposely go and memorize it because it comes from here. Okay. All right. Then after that, we talk about model class. Model class means a mode. All right. So the highest bar in histogram, okay, means the model class. All right, the highest bar. Okay, so please make sure you remember these. Sometimes they will actually ask you, okay, from the histogram, what is the model class that you have? Okay, all right. Then after that, we have the shape of distribution. So for the shape of distribution, we are not going to discuss it now. I will discuss this after we learn the very last type of graph that we have. Okay. So these are all the details about the histogram that you need to know. All right, there are a few important words here, important terms here. And after that, of course, the most important thing is you need to aware that we have unequal width histogram. Okay, and then in exam, usually they like to ask unequal width histogram. And I will tell you that if you are careless or maybe when you are not checking before you draw, right, very easily you will draw the wrong type. Because usually students, when they want to draw histogram, they forget to check the detail and they always draw the original frequency, the equal width histogram for me, which is the wrong one. Okay, because in the exam, they will not tell you, this is an unequal width histogram. They won't tell you that. You have to check it on yourself before you draw. Okay, so that's why a lot of students, they forget to check, and that's why they always draw a wrong histogram. Okay, so in the next video, I'm going to discuss with you, okay, to check how to draw the unequal width histogram. All right, so for this video, you just make sure that you understand all the important terms first. Okay.